face-to-face and interactive. I hope that we can do at least a little bit of that, that we can look at the data and also go through that, and perhaps some of you might even start to upload some protocols or just try it out. It's not a problem if you start. We can delete that later or keep it on. But if you want to just use it as a playground and try out what it's doing, then please go ahead. As long as you don't save it, it's not, or not make it public. Nobody else will see it anyway. But even then, we can clean that up later. Therefore, please go ahead and try it out whenever you want to. I will have some intermediate times where I just also show the tool interactively, and then you can see if there is something going on. I would also like, when something is unclear, that you ask me directly, because then it's not so I'm talking to my monitor. I would like to talk to you and not the monitor, and I don't see you actually. Therefore, I cannot see what you are doing. But if there is something unclear, please let me know. What I want to start with is why we do that, and this is something which I hope that this gets into also for especially young researchers, that they understand that this data management is not something which is forced on you, but that you have chances to, or that you can profit from data which other people have produced. And I think the tool Drew just showed it is very much in this direction, that there is something where you can profit from data others produce by, for example, understanding how to bring your nanoparticle into solution, because other people did that already. Yeah, and therefore, I really hope that we can establish more this creation of this cycle of the data life cycle, which we call that. Yeah, that you start with your experiment by planning what you want to do, then you do your data acquisition processes and analysis, and then most of the time people stop here and then they put that into a paper, and then the data is more or less what I often call as a graveyard, because you really have to dig it out again to use it and reanimate it. Therefore, I hope that with the idea of that this is then stored and then shared, it really gives you the possibility to get to data of other people faster. Use that in your planning of your experiment, because then you can already take in all the information you have from these other people, plan better, and also avoid experiments you don't have to do anymore because somebody else was doing it. And if they are managed in a good way, that you can trust these data, that you know where this data is coming from, how it was produced, what are all these kind of little things which might change the results, then these data will be much more useful than even in a publication, because you first have to find it, and then you have to find exactly the conditions, and these might be in a protocol which is just stored somewhere else, or it might be not available at all. Yeah, therefore bringing all these things together is very important. This is a very complex thing, but just look at the colors first, because that is what people are supposed to do. Yeah, and we have these different people in data management. Yeah, the first is the creator, probably a lot of you, analysts, then curators, which make the data available, then the data warehouse manager, and the customer, which is just somebody using the data. And I try to make it simpler, but by just putting in the colors, that the creator is more or less responsible for most of the time already the objectives, the design approach, and then the collection even if the customer has definitely for the first two parts definitely an influence in that. Yeah, then you have the analyst who's doing the processing, validation, model building if necessary. The curator is doing quality control. The data manager is sharing or storing and sharing, and then you have the customer who is wants to see if that is useful for him and then apply it. But I hope that this becomes much more interlinked. Yeah, and this is something we are really planning or trying to do here as well, is that the creator understand that they are in principle, that their work is not stopping here at the collection. They have to go through this quality control. The technical storage and sharing clearly is the data management, but before and what is stored, how the data looks like, and what information is associated to the data. This is not something the data warehouse manager decides. This is something the community decides, and therefore at least all the three people, the creator, the analyst, and the curator, but also the customer, the user, should see if this data is really of quality. And I'm not here talking about that the experiment is done correctly. I assume that you are all capable people and you know how to do the experiment. But it's more that the data is in a form that other people can use it and they understand what the quality is actually of this data. Yeah. Finally, and because I want to interlink that, yeah, and you see all these crosses that many people are really responsible across a broad variety of tasks. We now start to establish a data shepherd, which is more or less overseeing all these things, yeah, and bringing the people together, understanding the different requirements that people have, yeah, and try to optimize that also with technical solutions. Yeah, and ACEnano is perhaps one way of technical solution to improve this data sharing quality control, but also in a high level, and very much bring the idea of the design approach and the protocols, yeah, how that was really done into the picture of data, pure data management. Yeah, it's not an Excel sheet where all the values are in, because that might be random numbers. It's really more what we call metadata. Yeah, the data which is describing the data. This is much more important because you have to know what methodology you used, how the sample was prepared, what the experimental setup, the machinery was, and so on and so on. And bringing that is a lot of work, and therefore we need some people who also provide that, consult this whole process, but then also try to work together with the managers and the curators and other software developers to provide the tools for doing that. Finally, yeah, how to share as the last question. I see you in the both areas. Yeah, these kind of people. You are on the one side providing data. On the other side, you hopefully use data from others. Even if you read publications that is using data, therefore these groups are clearly largely overlapping. And then you have in between something where these projects collect data from different sources, and ACEnano is in here as something which is clearly concentrating on physical chemical characterization data, but we want to bring that all together into something where then this data is together and could be used, for example, for the ACEnano decision too. Yeah, then you would have one place where you would look at it, but this is only possible if the data can do that. Yeah, and therefore we need this magic, what I call the magic here, to prepare the data also technically in a way that this is done. But again, this magic can only work if the people are really willing to do a little bit more work on their data before they upload that to our data warehouse. Okay, but now back to the main topic, the ACEnano Knowledge Warehouse. or infrastructure. You saw, I think I said that already, I posted the link to this presentation in the chat. There are some links there and then you can directly click on this link and don't have to type them. Therefore, I hope that this will help you to easier start with looking at the knowledge infrastructure and play around, and if I'm getting boring, then you can stay in the data warehouse and do some work outside of this or in parallel to this. The topics on the data warehouse, we have 3 topics we want to cover today. The first one is a continuation of what Peters was telling you, is the method description, and this is mainly what he already showed as this info button in the decision tool, but I want to go much more into that and explain what you can find and what we are hopefully at one point of time even more provide as we do at the moment. Then we are talking about data and protocols and how there is a clear difference to a normal management of these 2 things, which is mainly as separate entities. ACEnano is really here trying to build a new paradigm of bringing these 2 things together because they are belonging together, and then we will show how you can use that. As I said, one was already the decision tool, but there are also ways to analyze, visualize the data in a common format and therefore bring together different data sets of different people and see what is the difference and where are they similar. Is there a difference when you do the experiment in different labs, or is that a standard proto or tool which is very robust and therefore it doesn't depend where you really do it or who is doing it. Yeah, it's easy to learn. And what I think you saw from the presentation earlier is that we have something which are really clearly standard cases, but then also very, very specific analysis tools, which are perhaps done only by one specific lab or one specific company is providing the machinery for. These are, as I said, we have a couple of links. The first one will be the most important one. Yeah, the ACEnano knowledge infrastructure. You can access that there. But then we have a lot of tutorials. We have earlier training, which will come later, but you can also then check out if there are any other information, description on that, a post about the ACEnano knowledge warehouse. Therefore, please go. Feel free to look at whatever will be helpful for you when you want to and start to use the tool. This is the entry. When you go to the link, you will see this button here, or the entry. You can directly use Google to sign in. Just use your Google account. Therefore, you don't have to sign up. You can just log in. If you don't have Google, then there is also the way to sign up with a specific ACEnano account. But we thought that for most people who just want to look at it, it's much easier if they use one of the social media type of input. If you do that, then you get to this starting page, and I will discuss that in more detail. But one thing you will see is that ACEnano, as it is now, is very much focusing on the techniques, not so much on data or specific particles. It is really something. ACEnano is a method development and not a data production project. Therefore, these methods are really the the focus of this project, and therefore we also present that in the data warehouse in this way. When you remember back to this interaction of different, perhaps I just go back to this slide very quickly. When we now start to combine these, then and hazard data with FISCAM data and so on, then it's clearly that the nano aspect, the nanoparticle aspect will be the central point and not the protocols anymore. But we will probably handle that in two different areas. Yeah, therefore, at the moment, I would assume that ACEnano will stay mainly a resource for methods with underlying or with data which is produced with these methods to show how it can be used, for what it can be used, and what the results are. But as I said, there are different ways to also then have a look at the data itself inside ACEnano, but especially when you then want to combine it with other information, other data sources like hazard, exposure, and so on, then there will be a different way to access the ACEnano data than really very specific nano material focused. Since, as I just said, the techniques are the main purpose, the starting point is the technique catalog, where all these techniques are explained or described and presented. It's clearly that this should be, we want to have that as the central catalog for ACEnano provided techniques, but in the long run, this should also be open to other methods, and especially after ACEnano ends, this should become, or it is already a public source, but then also this will be more open to techniques which come from other projects or other companies, labs, which can then also showcase their technique in the same format. But at the moment, as I said, it's mainly focusing on the ACEnano techniques. We want to provide here something which you can really use to find, select, and learn about the techniques. Select clearly is what we just presented, the decision tool, because that is the help for selecting that what is possible with your specific material. But we are integrating what you already saw. We are integrating there the techniques catalog already in there to then have a link to more description of what is going on. It is also something where we want to show what we did, the methods, but also the outcome, which means data, protocols, specific protocols, and so on. And this I already said that it is really much highly integrated, or we are still working on the integration, but at the end it will be really highly integrated with a support tool, a decision support tool to go back and forth and see what is that. Yes, I know it can be used, but can I use it? Yeah, because that is then the next question. You need protocols, you need more description on the technology, or you need providers who can help you with using the technology. This is the starting point. This is really on this entry page for the ACEnano warehouse. You will directly go to a listing structured on the techniques, and it's focused on techniques where we have protocols or data sets. Therefore, you will on the first page, on the home page, you will only find the techniques where we have then also protocols and data, but there is also a link to the full catalog where then all the methods are described, independent on if they have data there already or not. And if you then click on one of them, here, for example, the NTA analysis, you will get to this kind of quick description, what you have in there, the different materials, the different methods, but then also be linked to the corresponding protocols and materials and data. These are all the existing endpoints, techniques, endpoint combinations, that endpoint like size, shape, and these kind of things, and then the tools or the techniques which can be used. But that is more or less exactly what Ruth was just presenting, but as an overview of what is possible, what these different methods can do. For example, here the size distribution. This is exactly what Ruth just said. The only difference is that you already link that to applications like risk assessment or regulations or so. Good, let's move over to looking at it. Let me just print out. As I said, please, if you have questions, ask them, because I'm still hoping that you're hearing me, and I like this, seeing all of you millions of or infinite amount of times. As I said, if you have questions, please let me know, ask now, and just raise your hand. I'm not sure if you can raise your hand, but if you want to say something, please go ahead whenever you have something to say. Otherwise, I jump in. Logging in Google, yeah, I'm already logged in, therefore if you are going to Google, then you will be asked which user account you want to use, but that is more or less the same. Okay, let's go to the starting point. This is exactly what I showed in the slides. Yeah, you have here the catalog of techniques, and when you scroll down, you have here the full catalog where you have really all the different methods, and then the endpoints you can use for which you can use this method. Yeah, but going back to something we have data, or we can look a little bit into detail. Ruth was mentioning the AF4 method. Let's start with that. Just go through the fields. Yeah, you have a really short description of what the method is doing, how it is working. And then you have the endpoint listing. Here you only have the size distribution as the only endpoint which this method is used for. You can see the benefits here, where you can also show what the size range is, for example. This is all based on the information Ruth was collecting for his decision tree, yeah, because he will then use exactly these size ranges to see if the user has provided something which is compatible with the AF4 method. You see here the technology readiness level. I'm not sure, probably most of you are not know what that means, but it is in principle just a criterion from 1 to 9. It's not to 10, but the highest one is 9, which is a little bit funny, but anyway. How validated your method is. Yeah, one is really very experimental, and then you go through different stages like inter lab testing and so on. And 9 means this is really an established and probably also commercialized technology. Therefore, this AF4 is really something you can use out of the box. And it's highly evaluated. It doesn't mean that it's regulatory accepted, but most of them, if you go to these high levels, at least they are discussing if it will be. You have the market sector, clearly nanomaterials. Yes, this is clear, but we have this one because it is already so much validated. It's also available for commercial research labs. Producers and suppliers might be target market, and then the material users. But probably mainly here, because then you go into regulation and they would use it for in the dossiers for their materials. Okay, that's clear, but this is more or less the minimum amount of information you will get, and then you, as I said, but I will go into that later, you have the protocols and so on in there. Let's look at another example, because we want to provide more, and for that I use the single particle ICPMS. I'm not so good in the acronyms than Ruud is. You find here similar things. It's a little bit less specific up to now on the readiness level and so on. This will be added at one point of time. But what I wanted to show is that you can have then here links to detailed description. Yeah, this are PDFs. It's not that structured, but then you are really going into something. ACEnano is collecting at the moment really very detailed description of all that. This is something also Ruud is in charge of. Therefore, he is collecting for all these techniques a very detailed, and I don't want to go through all of that, but a very detailed description also on how the results are then interpreted and so on, and the reference and so on, and further. This will be, I hope that this will be extended, that for example, SOPs, standard operating procedures will be added. Perhaps also providers of the methods can be added and so on. Last example, just because that is something which is also a little bit different from the information we have already in here, is electrophoretic light scattering. Because that is something which is very much provided by someone, and therefore we then have also the link to the external material from Marvin. They are also partner in the ACEnano consortium. Therefore, you will link directly to this to the web page, where you can then get information. And here you see already, yes, they are company, therefore they would also probably run that for you or sell you the experiment, either the experimental out or the results or the equipment you use for that. Good. As I said, if you like, please go ahead, look a little bit. If you see what is available for your technique of interest, some of them are quite underdeveloped from the information I probably showed here, the best examples, but we are working on that to make that really a source of information which we can use for finding what you want to have. And if you are linked by the decision tool to a specific method, you can go in there and have a look at what that method is doing, and if there is already interesting data of materials which look similar to yours, or how you get, for example, something into the correct state to then use for this method. Good. Second part, now to the data and the protocols, and I always call it protocols and data because we are really looking more on metadata which describe the protocols than the data itself, because data is in principle a couple of numbers and perhaps some other units or whatever, but to know what these numbers are standing for, you need the protocols, you need to understand what people did. This is the metadata we collect. To show that ACEnano went into a process where we really wanted to not have these as separate entities, even if they still look a little bit like separate entities in the warehouse. But it's not something that you have a protocol and then you do everything and then you have the data. No, they are really interlinked. Yeah, you have the original sample which has to be described, which is some kind of data. Then you go in the sample preparation protocols. This will create a prepared sample. Then you do your measurement. You have the raw data. You do the data treatment, and then you have the process data. And therefore, this is all, and all these steps here, the blue things, have to be described to understand how you get from the raw data to the process data, for example. And therefore, all these things are in, and we try to build a system which is really trying to collect this data in a format that it's structured in a way that after that you can easily see if the machinery was different, and the hopefully final solution of the data warehouse will really give you then ways to, for example, filter the data by a specific machine. Yeah, down to a specific machine. Clearly, you can filter in by the technique and the endpoint and the nanoparticle. This is easy, but you can really then go down to even much more detailed filtering. That you say, okay, I have this specific equipment at my lab. Which data could I? Oh, which data was produced in a similar setting? The data upload, yeah, you produce your data, but the data upload is then also in a similar way. At the moment, it's we first add the protocols, and then you create something which is which we call a data workflow, where you select already provided protocols. Yeah, this is might be in some situation a little bit suboptimal, because you might see that you will miss some information, and then you have to go back to the protocols and add that. It would perhaps be nicer to do that during the data workflow execution, but for handling it was easier to do it this way. Therefore, you first create the 3 types of protocols you need, and then you go into the data workflow, which collects description of the sample, collects all the protocols you need or which you executed during the experiment, and then you do the data upload, which, as you see here, it's not really the major point. Yeah, it's very different to others, where this whole I'm not sure if you are in other projects, EU projects already, but they try to use that to cover many of these things in data templates, which become then very, very complicated and hard to fill in. Here we really separate the description of the metadata and the data, and hope in this way to make it a little bit more structured and easier to fill. Okay, I can jump over that, but in principle, these are just the 3 types of protocols and the things you have to put in there. We have a general part where you have always the contact person, protocol name, the endpoint, and so on. And then you have specific steps and also the information in a structured way. And what I mean with structured way, you will see in a second. Yeah, this is the general information. As I said, you need some name of a protocol, which is arbitrary text, which should be somehow descriptive. We have a version control. Yeah, therefore you can have different versions of your protocol, but you can also have variants, and this is something which really is important. A version is more or less, okay, it's your, and you optimize your protocol a little bit, and then you would have a version. It might be, but it might be also variants that you, because you now use a similar protocol on another material, you had to change a little bit the things. Yeah, you had to increase the measuring time, or the media, the solution media is different, and so on. And all these things should be described, and therefore you have different variants, which might be very small differences. Yeah, as I said, just the medium, the solution. But all these will then result in a different protocol. Therefore, these protocols are definitely not SOPs. Yeah, they are not something standard. They are really very, very specific to what you did in this one experiment. This leads to a lot of protocols, or we hope that this leads to a lot of protocols. But in principle, since we are then able to compare what that is, because we have it in a very structured form, you can easily see, okay, this is mainly the main part is every time the same, and then you only have to optimize a little bit the time you steer something or something. Yeah, therefore, it will generate a group of protocols which are doing the same thing, but you can also then see the variances people needed to do to optimize the standard procedure for then a specific sample. And I think this is very, very important to understand how, what people are doing to make methods useful for their setting, and how much often or when to use some specifics. Yeah, because an SOP has to describe a general procedure, but you don't know when they say, okay, steer for 5 to 10 minutes, then you don't know if that is just a random number between, or if there is some kind of optimization needed, that sometimes you only 5 minutes is enough, sometimes you have to steer 10 minutes. And all this we hope to cover by this. You can then put in description references. Yeah, this is all general, and then we always have a contact person there because we want to also bring people together that they can ask and see who was doing that, and if there is something missing or unclear, or if you ask to have more information or help, yeah, then you can go. Then you just select your technique and endpoint you want to upload your protocols for, and then you go into these stepwise sample preparations. And here you have a list of actions, predefined actions, but you can also add one where you just select, for example, suspension, vortexing, the next step, and then you go on and can add as many steps you need for your sample preparation. Yeah? And when you select here something, you will get additional information, or will be asked for more information, like the medium, volume units, or weight of the whatever you want to provide, the sample concentration, and so on. Yeah, starting phase, end phase, and these are, I think, also very important to show also that you say, okay, you want now to find ways to go, for example, from a powder to a solution, what was already used, for this, and then you go to the next step, and so on, and in that way you can then see that, and at the end submit your protocol. Yeah, then you have your sample protocol. The measurement protocol looks similar, but now we have very specific asking for the equipment, and this can go down to the pipette you are using. Yeah, we really encourage people to not only describe the main machine, which you bought for $500,000 or $1 million, but also down to very specific things like pipettes or some other things, which might have an influence on the result. And then you describe a little bit of what the data set looks like, and then you can have here parameters, different parameters you provide, like temperature, like pressure, or whatever, what you know your experiment much better than I do. Okay. Again, you submit that, and then you end up with something like here for the UV-Vis, a sample, the sample analysis by UV-Vis, and then you see here the information on the spectrometer, the type of the experiment, the specific model, and here then the parameters of setting. Yeah, what you have is start wavelength, and so on, scan speed, which are very specific to the experiment. to the experiment, and therefore you are relatively free here to do something, whatever you want or what is needed. At the moment, we don't really have some kind of standard parameters we ask for. Therefore, it's also something which we want to use ACEnano to get to the metadata, to the coverage of metadata which is needed for the different experiments. Therefore, we will probably or we will introduce necessary parameters at one point of time, but at the moment it's the necessary parameters are very high level, like for example the software you are using as well as the instrument, that's clear. But this will be also be refined that there, if you select a specific experiment, then you will be directly asked for these types of parameters and settings. You are then also able to provide human readable text. This would be more like what you are normally used to see as a parameter. The different steps you have to go through. If you saw protocols IO at one point of time, you know that we more or less stole that from there. But it's really nice to have then also this kind of presentation. And these could be even, you can include their pictures and tables or whatever other information you think is needed for this experiment. And we have really nice examples on that. Okay, another looking at data. And as I said, go ahead and ask questions. Starting with protocols, I think the UV-Vis is a really nice example where we have a couple of measurement protocols. This was one of the round robins. Therefore, you also see here that we have, for example, measurement protocols from different partners, the University of Birmingham and then the BFR, building that in. They should look very similar, but if you look here, let's go, perhaps the University of Birmingham was designing this experiment. That is what you also saw, and it also is a little bit extended, for example, with images of the spectrometer. Here, Eva is here, perhaps if she wants to say something about that. I'm really not the expert, but you can also then include some images, for example, for quality control. I'm coming more from the biological side, where you then perhaps put in some pictures of cells to show that these are really living cells, these kind of things. And in the protocols, you could then show, yes, do a quality control. This is a good example. This is a bad example. And give as much information for the user as possible. But you also see here that they use the specific information where I had some screenshot before, the model. But if you now go, for example, for BFR, it was a round robin, but they didn't have the same experiment machine. Therefore, it is a different machine, which might have an influence definitely on the parameters you have to set, but perhaps also on the experiment. Sample preparation is similar there. This is only from Birmingham. It might be that we don't have. No, we have 2 data sets, and just something to be aware of. Since I'm part of the ACEnano project, I see a little bit more than you do, because we have open access data sets. We have things which are still restricted because they are still in public, or either most of the time they just wait until the data is published, and then this will be released also publicly. For other people who are not there, they only see the open access, and they also only can upload open access data. Yeah, this is a limitation we have. Good. Sample protocols, because they have here, and I don't want to look at the restricted, but since they had to provide a sample protocol as well, they said, okay, we used exactly the same as Birmingham, therefore we don't have a specific protocol for our experiment, but since we used another machine, we have to have a specific measurement protocol. Yeah, and then you see here, what do? They vertex first, then they diluted that, and with all the parameters of what the dilution was. And you always have, we started with a liquid and we ended with a liquid. Yeah, if you start with a powder, you first would need some kind of dissolution process to go there. Good. The other one is the AFF, but very similar. Also, that was a round robin. Therefore, we have quite some data here. You also see that some of that is still restricted. But you also have overlap of these different ways to do. Probably here you see that we have from the Helmholtz data sample protocol, a sample preparation protocol. We don't have a measurement protocol from them, therefore, no, the other way, sorry, from the Center Swiss Electronics. We don't have a measurement protocol. That might be either that they used exactly the same thing, because that is a Postnova provided machine. They also don't uploaded the data, therefore it might be also that they are still in progress of uploading the protocols as well. This is, I don't know. I will check to have more examples and then also go into the differences. For data, also some let me jump directly to the UV-Vis example. We have two data sets here. Yeah, also when you look at the data, two different ones. I already said the BFR is still restricted, even if I don't really know why. But this is then the data set, yeah, where you follow this workflow. Perhaps I should go first to the workflow. Show that as an example. When you want to add a new data set, you jump into these data upload workflow where you have to select the technique. UV-Vis. Where am I? Then you can select the endpoint, and then what you have to do is then prepare these different protocols. Yeah, and for some reason I should have done that before, because we don't have that. We only have average size dimension, I think. Then you will see, okay, here is something I can check. Yeah, there is a sample preparation protocol already there, and this is what I said. Yeah, the problem is that you have to first define the protocols. Well, not the problem, but you have to first define the protocols, and then you can go with it. Okay, I'm really running out of time, but I think I just leave the. Oh, yeah. I think this is the more important thing. Then you go to the measurement, and then you will describe your sample and so on. Therefore, I think please have a look, see what you want to do, but just let us go quickly to the data. Where am I here? What you will see is that some of the data sets will have these, or you can look at the data set as well, and some of them will have this icon, and then you will be linked into our visualization tool, or browsing tool for this data, where you can then see a different, or the results already presented in this tabular form. Some of them are really just data sets which are in a very specific form for this experiment, or Excel or CSV files which you can then download. We try to improve or include more and more of these techniques also in this way, that you can directly look at them in the data warehouse. But this is very customized, or has to be very much customized, because these very different methods produce very different data, and therefore these input procedures have to be really made for each of these technique endpoint specification. We concentrated on the round robins to show a little bit on what is possible, and this is the last part of the presentation, very quickly, because I'm running out of time, and I wanted to have a little bit of questions. This is what I showed. I just run over that, but please, you have the link to the presentation, therefore you can also look at that again. Yeah, here you see these different points. Yeah, you have to select the protocols, and then you have to also again here description and information on the sample and the nanoparticle you are looking at. Yeah, because that is not yet in the protocols. And then you go into that. I showed all these directly. The advanced cases are now the things where we said, okay, we want to also show that this whole concept will then help in the analysis and the reporting, especially if you have multiple data sets you want to compare. Yeah, and therefore we created this upload scheme that you get that into this form of the visualization, what we call Edelweiss data. And then you can go with that. You can in there manually filter or search or just look at that. But there is also a way to directly access it. And this is where it becomes a little bit problematic. First, here we have, and this is the important thing, this data is not just what you see here, but you have also the metadata tab, and there you see all the information which you provided in the protocol in a way which is not very nice. Yeah, if you want to look at it, it's much better if you go to the web interface. But if a computer wants to look at it, this is the way to do it. Yeah, because now we can find what the technique is, we can find what the machinery was, and so on. All these information in a structured way that a computer can read that in and compare it. And this is exactly what we do. There is a way, and this is a completely different field and a presentation, half a day presentation, how you work with these APIs, but in principle it's a way the computer can access this thing, go in there and do the analysis, or try to work, or you can write scripts, somebody can write for you scripts to do the analysis and then get to this comparison of a single data set or between different labs. But again, this is very customized for a specific method or a specific study like these interoperable, these round robins. But if you have that, you can then write automatically nicely reports and get that in. This is how this whole works. Yeah, it's Python in this case, Python language, programming language, but in principle you can also use different ways. But just it needs a little bit of programming. Yeah, it's not something which is out of the box, but in principle you can now automate the whole thing, which mainly some of you are doing in Excel or something like that. But if you are interested in that, I'm happy to help you in going from something which is Excel to something which is scientific. Okay, this is then the same thing, yeah, for the UV-Vis protocol. Yeah, you see that now also these reports in the data warehouse, but these were exactly produced in the way I just showed via these scriptings and in the way helping automate that. And when you look at that, this is for one data set, we have multiple. You could then download these and then plot them together. And the nice thing with this experiment was that they more or less looked exactly the same, which is nice to see. That was it. Again, just quickly, here are more links, also to other trainings. Please go ahead and have a look if you are interested. You also have here the support, which this email will bring it directly into my mailbox. Therefore, If you have questions, just send them where I will see them. And if you have questions now, we have 5 minutes, something, or perhaps more. That is depending on how much I can use your break time. I'm here as long as you want to talk to me or have time to talk to me.
Thank you, Dr. Exner, for the excellent talk. Now the paper is open for questions. Please open your microphone and ask a question to Professor Exner. Shall I start with, let's say, a typical question for all these projects? I mean, my question concerns the sustainability of such a kind of warehouse. Do you have any business plan for the sustainability of this product?
Yes. The idea is really that at the moment we are discussing, or this is going into another project which is called Nano Commons, which I quickly showed a little bit of the main ideas from there. What we are doing at the moment as a community is trying to identify important data sources and try to convince other people to use it. And this is what I also do here, but in principle the Nano Commons is this picture here which I showed. The Nano Commons tries to do so, and in identifying these things, that for example ACEnano is becoming the standard FISCAM data warehouse, we hope that then additional information is coming, or additional project will use it more and more often. And the other example is ACEnano Mapper, which is in principle already doing that. This database is now being reused in many different projects, and in that way it is sustained. And I think that is the way to go. ACEnano will be sustained. The first project which will sustain it is Nano Commons for an additional year. But as I said, I really hope that this idea of different projects are reusing the same technology, and perhaps multiple of these. We have the ACEnano, for example, very specific for FISCAM. We have NESIT, which is very much on exposure, in factory exposure. I'm not sure what the word is. I have to look it up, but it's not. Or then Nano Commons with ACEnano Mapper. This is still an old version, but ACEnano Mapper has hazard, exposure, and many other data sources. But that in principle the projects are not creating a new one, but that they select the data warehouses specifically for their data and bring it in. This is the way how I think this, or I hope this works. ACEnano is perhaps the first version of it. There are clearly ways to improve on that, but this, as I said, this is hopefully going in the follow-up project. From the company side, because we're doing that in Edelweiss Connect as a company, we are clearly committed to sustain that in a way that we will provide that for the time being. We are not, and as a public resource, we are a little bit limited on the new developments, but as I said, this is hopefully coming from the additional projects we are in.
Thank you very much.
Long question to just say we will sustain it.
Okay.
Thanks.
Are there any other questions? So as I understood,
yes.
Okay, Sahira, yes, please.
Thank you very much, Dr. Exner, for this nice presentation. A lot of information. Maybe you mentioned it perhaps, but I didn't understand. So how this data exchange works in terms of rights for a provider and a user? Let's say that do I need to you mentioned something about open access, but is there anything to do with to be a member of this project, or how does it work?
No, if you um, if you are willing to provide it publicly, then everyone is able to. You just need an account, and then you are in. Yeah, that is the way this normally is done. I'm not sure if I can quickly jump to that, but at one point of time you will be asked for the license. Yeah, and then you have to provide specific information on what license you want to use. For ACEnano members, you can have these different types of license. Yeah, that you say only for me, only for the project, or public. We are happy if there is a bigger project and wants to have this kind of what is it, embargo period, yeah, that you say, okay, we want already to use it, but we want to publish it and then release it after the publication. We can definitely also set that up. But the normal way is that everyone who is not ACEnano would have the possibility to make it public. It stays your data. This is always the one of the concerns. Yeah, if you transfer something into a data warehouse, it's still your data. You have full access to or privileges to do whatever you want with it. But we are trying to get data public. Yeah, therefore, ACEnano, we are definitely pushing everyone to make it as public as possible. But you can still restrict it to non-commercial work and so on and so on. Yeah, it's really what you decide on the license for your data, and you have to, because it's you. You are the only person who can decide what are other people's allowed to do with your data. But if you want to use it, go ahead. If you are, yes, I want to make my data public, you can go in there and make protocols public, data public. And as I said, if you are a larger project who wants to share inside the project first, but then says, yes, but we want to make it at the end, we want to make it public, there are ways to support that as well.
Thank you very much.
Thank you very much. So we have to conclude now. If there are any other questions, please contact Professor Exner for more information. And now we have the lunch break. Thank you very much, Professor Exner, for the excellent talk again. We'll continue with a lunch break and we will be back in half an hour. Thank you very much. See you in half an hour after the lunch break.
As I said, if there are any other questions, I can also stay a little bit longer.
Okay.
You have now
Yes.
now have a break, but I don't want to keep you away from your coffee. Therefore, if you want to make a break, that's fine. If somebody stays in,